very important things that I have here is options. In a previous slide, I have not talked about the options. As I said, friends, options are going to be the optional one. So what could be in the option? Just giving you an idea. It could be a timestamp. It could be a record route taken option, or you can specify the strict route. For example, we are sending a packet to specific country, and let's say we wish to avoid a country like Pakistan, through which I don't want my packet to travel or through any router of Pakistan, for example. Let's say that country is coming in between, right? Then those kind of things you can do the settings over here in the options, right? Now, very important point that has been reflected in this slide is this: how much overhead with the TCP along with the IP, along with the IP. If you don't know, let me tell you, even your TCP header minimum size is 20 bytes. So let me take one example that is my favorite example. I have already taken before also, but still I'm giving you. If not taken, let's understand that. For example, let's say 1 byte of data is generated by Telnet. Telnet is an application layer protocol. 1 byte of data generated by Telnet. And you want to send this 1 byte of data. Now Telnet is an application layer protocol. So Telnet will pass this data to whom? Yes, Telnet will pass this data to whom? TCP. So what TCP does? TCP adds its own header. What is the length of the header? Yes, TCP header length is 20 bytes. So TCP अपना header ऐड करेगा 20 का, ये IP अपना header ऐड करेगा 20 का. तो अभी इस टाइप की सिस्टम की एफिशिएंसी क्या हो गई? या तो you can say throughput. What is the throughput of such a system? Throughput is nothing but 1/41, right? Because in order to pass the 1 byte of data, you need to add extra 40 bytes of header, 20 bytes for TCP and 20 bytes for IP. And that was not actually, we have not counted the underlying technology overhead. That means data link layer and physical layer, right? Even you ignore that, still you are getting the overhead of like this. So my efficiency is going to be 1/41. So this is an overhead, but it is the requirement, right? So that is what has been explained here. 40 bytes, which goes in the header, plus application layer overhead. That also Telnet header I also not counted. Let's say HTTP header could be there, right? So this is how you have to understand. This is very important slide because I gonna take you to the fragmentation and MTU and everything. Because if you look at this part, as I said here, there is a 13 bits for fragment offset, and there are flag, right? So fragmentation is done by intermediate router. Why it is done, I'm going to explain you. Let's say there is a sender over here who is sending the data, and there is a router here, this router. I hope you are able to see my pointer. So let's say there is a big package coming here, big package like this, and this router has a restriction in terms of MTU. What I mean by MTU, network links have MTU, and MTU is nothing but a maximum transfer unit or a maximum transfer size, whatever you call it. It's a maximum transfer unit. It's not GTU, it's an MTU, right? Maximum transfer unit. It's the largest possible link level frame. Depending on the underlying technology. What do you mean by underlying technology? For example, it could be an Ethernet. Ethernet is an example of an underlying technology. Wi-Fi is an example of an underlying technology. So based on the underlying technology, you have a size of MTU, right? Now, large IP datagram divided within net, one datagram becomes several datagrams. So as shown in this diagram, this was the one datagram which has a one header. I don't know whether you are able to see the header in the orange color or not. But now this datagram has been divided into 3 parts. Part 1, Part 2, and Part 3. So what this router has done actually, this router has done something called fragmentation, right? Because these 3 packets have been fragmented out of this one, so it reached to this router, and here is the destination. Now this, on the destination when it reach, somebody has to do reassembly, right? Who does that reassembly? This router is going to do the reassembly, or we can say that the receiver can also do the reassembly, right? Well, let me explain you. One datagram becomes several datagrams, reassembled only at the final destination. See, reassembled only at the final destination. IP header bits used to identify order related fragments. Now, the question that arises here is, how are you gonna decide these 3 fragments? These 3 fragments are the part of this original packet, because my IP, which is at the network layer, is connectionless. It's quite possible that fragment 1 and 2 might be received here, but fragment 3 might not be received. In that case, you need to retransmit the fragment number 3. And after doing the retransmission of fragment number 3, you need to do the reassembly, right? So IP header bits used to identify order related fragments. So we're gonna take an example to understand how the fragmentation is done and then how the reassembly will be done, right? So let's go in that detail. Data link layer frame, which has been shown here, as you can see in this diagram, there is a header over here, right? And there is a trailer. As you know, data link layer will add the header and the trailer, right? Now, when I'm talking about an Ethernet, and when my data size of Ethernet is less than 46 bytes, that means the data which is received by a data link layer, including the higher layer header, is less than 60 bytes. It does the padding. The reason this padding is required, see, there are two entities we are talking about now. One is MTU, that is the maximum transfer unit, and then there is something called a minimum bytes, which is required. You can ask me a question, why this minimum limitation is there? See, if my data is less than 46 bytes, actually it will ensure that the data link length becomes this data means, you know, inclusive of header. This data we are talking about at data link layer. Now I'm just jumping for a minute, huh? We are at network layer, but just we are jumping for a minute to understand the concept. So this data link layer expect that 46 bytes comes from the upper layer, and if this 46 bytes are not coming from the upper layer, it does the padding, right? When you say the padding, why the padding is required? The answer is that at data link layer, you are doing something called collision detection, and if you don't ensure this minimum length, actually, I don't know whether you remembered or not, your UTP cable could be stretched maximum to 150 meters. Beyond that, you can of course stretch the cable. Cable तो आप 10 किलोमीटर तक ले जाओ, कोई मना नहीं करेगा, ground है तो. The thing is that after 150 meters, you are not going to receive the data because your signal becomes so weak. So in between, if you put the switches, it will work. Switch will work as a repeater, that or amplifier, whatever you give the name. Right now, when I'm saying just less than 46 bytes, you need to do the padding. The reason is that I wish to ensure that in a length of 150 meters, if there are two nodes, one is at the one end, another is at the other end. मान लीजिए node A एक 0 distance पे है और आपका जो node B है वो 150 meters पे है, केबल के other end पे, दो end पे है दो machine. And let's say if both the machines are transmitting at the same time, we wish to have that collision get detected. And that is the reason you are keeping this minimum length. Right now, we are not going in that detail, but that's what minimum, right? Now, you know, one of the field, before I will go with an example of a fragmentation, in the header, there was a field called upper layer protocol here. Hello, right? Upper protocol, 8 bits. Now, what comes in that protocol? That let me show you. So these are the protocols that has been used by upper layer, above IP. So upper layer means it could be a transport layer, or even at the network layer, you have a protocol at IP layer. See, this is IPv4, and IGMP and ICMP are the protocols which are on the network layer, but located above IP, right? And ARP and RARP are working below IP, right? So that information, protocol related information is put up over here. You can see the lot of examples, and these are the values. So if my protocol is ICMP, this value is going to be 1. This value is going to be 1. This value is going to be 1, right? If my protocol is ICMP, if it is IGMP, it's 2. If it is TCP, it is 6. If it is UDP, it is 17. If it is OSPF, it is 89, like that. Right? This is very important. One of the reasons why total length field is required in the IP header. Please understand here. Right? This is the total length field in the IP header. Why it is required? Because there is sometimes you do the padding. When you do the padding, you need to understand how much byte is data, and that is only possible when you have a total length field. So that is the reason why you need to have a total length field. We will take some example and then we will go to the fragmentation. Let's say there is a question in front of you guys. An IPv4 packet has arrived with the first 8 bits as shown. आपके राउटर पे एक IP पैकेट आया है, उसके फर्स्ट 8 बिट्स ये है हेडर के. देखिए हेडर ही ना, पैकेट आएगा तो सबसे पहले हेडर होगा. तो हेडर होगा तो देखिए 8 बिट्स कौन से है, 4 बिट्स वर्जन के और 4 बिट्स हेडर लेंथ के. तो ये 8 बिट्स की वैल्यू दी गई है आपको न्यूमेरिकल में. देखिए दिस 8 बिट्स were given to you. So let me mark this first 4 bits. These four bits are for the version, right? Can you convert this into the decimal value? What it comes if I convert this into the decimal? 0100. Yes, you are absolutely right. It is going to be 4. It's going to be 4, right? So your IP version is 4. That means there is no problem with these 4 bits. These 4 bits are okay. These 4 bits are okay. Then rest of the 4 bits. What is the value? 0010. If you convert it into decimal, what it turns out to be? If I convert this into the decimal, what turns out to be? 2. And if you know, I have already explained to you, the header length will give you the length in terms of 4 bytes. Hello, it will give you the length in terms of 4 bytes. आपका decimal value क्या है? 2. So 2 into 4 क्या हो जाएगा दोस्तों? 2 into 4 it's nothing but 8. लेकिन minimum length कितना होना चाहिए? Yes, minimum length has to be 20 bytes. That means the packet that you have received which has an issue in the header length field. So what receiver will do? Receiver will discard this packet. There is an error in this packet. The 4 leftmost bits 0100 shows the version which is correct. The next 4 bits shows an invalid header length 2 into 4, that is 8. The minimum number of bytes in the header must be 20. The packet has been corrupted in the transmission, so it would be discarded. Is it clear to everyone? Now, question number 2. In an IPv4 packet, the value of H length is 1000 in binary. In the IPv4 packet, the value of H length in the binary is 1000. When I say 1000, if you try to convert this value into the decimal, what value you will get, friends? Yes, you are right. 8. How many bytes of options are being carried by this packet? That is the question. Now, 8. See, header length always give you the length in terms of how much bytes. You already know. Length will be given in terms of 4 bytes. So 8 into 4. 8 multiplied by 4. Yes, 32 bytes. So you have a 32 bytes also, right? And out of that 32 bytes, what is the minimum header length without option? 20. So what is going to be your options? How many bytes for options? 12 bytes, right? 12 bytes for options. How many bytes of options are being carried by this packet? 12 bytes. That's an answer. Look at the answer. The header length value is 8, which means that the total number of bytes in the header is 8 plus 4, that is 32 bytes. The first 20 bytes are base header, the next 12 bytes are the options. I hope it's clear. Right. Last question. In an IPv4 packet, the value of header length is 5, again 5, and the value of the total length field is 0x0020. Now when I say 0x0028, what do you understand? This value is given in which format? Anyone? 0x0028 hexadecimal. Good. So can you convert this into the decimal? What is the equivalent decimal value? This is 8. So my base is, yes, you are right. Base is 16. So 16 raised to 0. Hello, 16 raised to 0. What is 16 raised to 0? It's nothing but 1. 1 into 8. 1 into 8, how much? 1 into 8 is 8. Plus 16 raised to 1 plus 16 raised to 1. This is the weightage of the next bit. This is the weightage of the next bit. Right? 16 raised to 1. When I say 16 raised to 1 is 16. And 16 into 2, how much? 32. So 8 plus 32, how much? And that's how everybody is saying 40. Hello. The two values were given to you. One is the header length, which is in terms of, which will give you the length in terms of 4 bytes. So my header length is nothing but 20 bytes. Is it clear to everyone? My header length is 20 bytes because my value is given is 5. And you know header length will be given in terms of 4. So 5 into 4, that is 20 bytes. And he's saying that, what he's saying actually, is saying that, and the value of the total length field is this, and how many bytes of data are being carried by this packet. So header length is 5, 20 है आपका header, और इसका value क्या आया 40. तो कितना bytes का data हुआ दोस्तों? 40 minus 20, 20 bytes of data, because 20 bytes of header. Look at the answer. The header length value is 5, which means the total number of bytes in the header is 5 plus 4, that's 20 bytes, no options are used. The total length is 40 bytes because we have converted 0x0028 into the decimal, which means the packet carrying 20 bytes of data. That is how 40 minus 20. So let's go ahead now. Fields related to the fragmentation. I already said, friends, that there were in the header. Actually, this is the now part that we are going to explore. Flag and fragmentation offset. 3 bits flags के लिए है, उसमें 2 bits defined है, one is unused, and 13 bits are fragmentation offset. So I'm taking you to that journey, which is very interesting, believe me. So the second row of the IP header, if you can recall, second row of the IP header, second row, identification, which is 16 bits, flags, and fragmentation offset. Now we are talking of this row only. Now we are talking of this row only with some numericals, right? So let me go to that part. So identification, उस रो के दो पार्ट कर दिए हमने 16 में. लेफ्ट वाला जो पार्ट है उसका नाम है आइडेंटिफिकेशन, which identifies a datagram originating from the source host. A combination of the identification and the source address, source IP address, must uniquely define a datagram as it leaves the source node. Actually, it is a primary key that he is talking about. If you combine a identification value and the source IP address, it's going to be unique. It's going to be a primary key in order to identify a packet generated by a source, right? Then flags, I'm explaining you in the next slide. Fragmentation offset is the offset of the data in the original datagram, measured in units of 8 bytes. Very important. It's measured in the units of 8 bytes. See, there are three things. Header length will give you the length in terms of 4 bytes. Total length will give you the terms length in terms of 1 byte. And fragmentation offset will give you the offset in terms of 8 bytes. In terms of 8 bytes, when I say, that means the multiplier is 8. Right? ગુજરાતી મીડિયમ વાળાને ખબર હશે, નાના હતા એટલે ગ્રાફ ડ્રો કરતા આપણે, અને આપણે એક એઝ્યુમ કરી દેતા કે ભાઈ 10 કિલોમીટર એટલે 1 સેન્ટીમીટર સ્કેલ, રાઈટ? આપણે 1000 કિલોમીટરના ગ્રાફ એક નાના એવા પેપરમાં ડ્રો કરી શકીએ બાય ટેકિંગ અ સ્કેલ વેલ્યુ, સ્કેલિંગ. Please excuse me if others are not understanding Gujarati, but this is just to break a monotony. So there was no important concept I said. So fragmentation offset is like that only, which will give you the offset in terms of 8 bytes. I hope आपकी समझ में आ रहा है, right? ठीक है. So now let us take an example. ये आपके दो फ्लैग हो गए, तीन फ्लैग है, एक अनयूज्ड है, ये जो पिंक कलर का है, पर्पल कलर का, which is unused, and there are two more flags. इसका पूरा नाम है एक्चुअली DF. ये D है ना, D को लोग DF बोलते हैं, D को लोग DF बोलते हैं, भले इस स्लाइड में D लिखा हो, but I request all of you to remember this flag as a, rather than D, you should remember as a DF. DF यानी don't fragment, do not fragment, do not fragment. M यानी more, MF actually, more fragments. There are two flags we gonna talk. Now see, when the flag is 1 bit, what are the values possible? When my flag is 1 bit, what are the possible value? Either it could be 1 or it could be 0. Yes or no? Either it could be 1 or it could be 0. Now the question is, who will set the value of DF? The value of DF is set by a source. The value of DF is set by a source. Source is saying to the intermediate router that I'm sending you a packet, and if my DF is set to 0, right, I don't mind whether you do fragmentation or not. But if my DF is set to 1, which has been set by a source node, if my DF is set to 1, I am saying that do not fragment it. If you cannot pass it, it's okay. You ignore my packet. You let me know you cannot pass it. It's fine. I will find out another way. But do not fragment my packet. That is the service requirement of a source machine. So DF by default it's 0. If source decide, the intermediate router cannot decide divide the packets. Actually, you can set DF equal to 1. Don't fragment. अगर वो 1 होगा तो बीच वाले राउटर को परमिशन नहीं है डिवाइड करने की. That's it. MF, more fragments. The meaning is that in the previous example, if you remember, friends, one packet has been divided into three parts. So after dividing the first packet into the 3 parts, that 3 parts got a number, let's say 1, 2, 3. So when my packet number 1 is going, it has a flag value MF. In the first packet, see, originally मैं आपको ये बता रहा हूँ कि ओरिजिनल मेरे पास एक पैकेट था, इंटरमीडिएट राउटर ने इसके 3 पैकेट्स बना दिए, राइट. इंटरमीडिएट राउटर हैज डिवाइडेड इनटू 3 पैकेट्स. नाउ what would be the value of MF flag in this 3 पैकेट. तो ये पहला पैकेट है, उसमें MF1 होगा. इसका मतलब क्या है, ये बोल रहा है कि भाई मेरे बाद भी कुछ और फ्रेगमेंट्स आने वाले हैं which belongs to the original पैकेट. इसमें भी MF की वैल्यू 1 होगी. और इसमें ये थर्ड पैकेट है, because this is the last fragment of the original packet, its MF value is going to be 0. So when my MF is 0, I have to understand that this is the last fragment of the original packet. If MF is 1, you have to understand it is probably the first fragment of the original packet or the intermediate fragment of the original packet. Let's look at an example. Suppose there is a packet with 4,000 bytes. And when that packet arrived at router limitation is that it cannot pass more than 1,500 bytes. So intermediate router needs to do the fragmentation. As I'm saying, friend, fragmentation is done by intermediate router. This packet is of course going to divide it into 3 parts because 1,500 limitation है. So 1,500 into 1,500 3,000 हो जाएगा और फिर 1,000 बचेगा. तो मुझे anyhow 3 पार्ट करने हैं. So there are multiple ways how I can do it, but remember, आपका जो fragmentation offset है, that will give you the offset in terms of 8 bytes. उसका जो scalar है, उसका जो multiplier है, that is 8 bytes. That means you have to ensure that आप उसको ध्यान में रखो जब scale ये division करो. तो कैसे ध्यान में रखना है? Let me explain you. So for example, I have a 4,000 bytes. So if I give a number to each byte, and if my numbering system is getting started with 0 like this, right, 0 like this, what will happen? My first byte number is 0 and the last byte number is going to be 3,999 because it started from 0. Total bytes are 4,000 bytes. Now I have to divide this into the 3 fragments. So what I'm doing is let's say I'm keeping a 1,400 bytes of data in one fragment. I'm keeping a 1,400 bytes of data in one fragment. Now the question from your side has to be, how you got to a magic number 1,400? Why not 1,450? Why not 1,300? Please remember, the number that you take has to be divisible by 8. The number that you have taken has to be divisible by 8 because my offset will give you me the offset in terms of 8 bytes. So here my first byte value is 0. When my first byte value is 0, if I divide it by 8, I'm going to get 0, right? And as I've decided, my total bytes are going to be 1,400, right? So what you're gonna do is you divide 1,400 by 8. When I divide 1,400 by 8, what the value I'm getting is 175. Hello, आप कर लो यार इसको. 1,400 divided by 8. So you will get 175, right? और आप जब यहाँ पे भी 1,400 रखोगे, यानी कि 1,400 से लेके 2,799 आएगा. तो नेक्स्ट बाइट की वैल्यू क्या हो जाएगी? 2,800. सो यू डू 2,800 by 8, so it comes 350. So this is nothing. 0, 175 and 350 is nothing but a fragment offset value. हमें 2 चीज डिसाइड करनी है. एक तो हर एक पैकेट, मान लीजिए ये पैकेट का आईडी था, ये जो पहला पैकेट था उसका आईडी था लेट्स से 5,000. तो ये जो उसका फर्स्ट फ्रेगमेंट हुआ तो उसमें फ्रेगमेंट ऑफसेट दो अदर पार्ट है ना, फ्रेगमेंट ऑफसेट एंड फ्लैग्स. फ्रेगमेंट ऑफसेट में वैल्यू क्या जाएगी? 0. और उसका MF फील्ड क्या होगा? MF इज ऑल्सो गोइंग टू बी 1 बिकॉज इट हैज मोर फ्रेगमेंट्स. देन यहाँ पे आईडी तो सेम रहेगा, तीनों में आईडी तो 5,000 ही रहेगा, ये तीनों में आईडी तो 5,000 ही रहेगा. यहाँ पे फ्रेगमेंट ऑफसेट क्या होगा दोस्तों? 175 एंड MF इज गोइंग टू बी 1. यहाँ पे फ्रेगमेंट ऑफसेट क्या होगा? इट्स गोइंग टू बी 350 एंड योर MF इज गोइंग टू बी, बिकॉज दिस इज द लास्ट फ्रेगमेंट, my MF is going to be 0. In all these fragments, your ID will remain 5,000. This is how you do fragmentation. और आपको 1,400 नहीं लेना है कि भाई 1,400 ही क्यों? तो यहाँ पे हमने ले लिया 1,480. तो आप करो 1,480 divided by 8. 1,480 divided by 8. तो आपका 185 आ जाएगा. ठीक है. So this is another way how you can do it. So try to understand and then in the next session what I will do friend is, here हम लोगों ने 3 ही फ्रेगमेंट किया था, 3 fragments. What we will do in next example, even this fragment, 3 fragments are received by some router, and there is a router where you receive this packet, which is maybe a different router. I will show a topology also. And this router cannot pass this data even 1400. So this packet needs to be divided into further 2 fragments. Fragment ka bhi fragment, jaise vyaj ka vyaj, like that. Right? So we will show that example in the next session. I hope you have enjoyed the session. Thank you for joining.